Hi guys, welcome to lesson 3-2 where we're going to talk about angles and parallel lines. In our last lesson we learned about parallel lines, or more generally lines and transversals, and we learned about the 8 angles that are created when two lines are cut by a transversal and the relationships between those angles. Now in this lesson what we're going to do is we're going to look at those 8 angles and see what happens when the two lines that are cut by the transversal happen to be parallel. So we're going to use some theorems to determine the relationships between those angles, and then we are going to use some algebra to be able to figure out some angle measurements based on the relationships that we know. First thing we're going to look at is this postulate called the corresponding angles postulate. Now, in our last lesson, we learned that corresponding angles are angles that are on the same side of the transversal in the same side of their corresponding lines. So for instance, angles 1 and 3 are corresponding angles. Angles 2 and 4, because they are on the same side of the transversal, and they're both on the right side of their corresponding lines. So 8 and 6 would be corresponding, and 7 and 5. And it turns out that if two parallel lines, and we know these are parallel because of these symbols right here, right? These arrows tell us that these two lines are parallel. If two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. And here's the down and dirty proof for you. Here's a quick visual proof. If this line is parallel to this line, okay, then I can slide this line over without twisting it. Remember, lines that are parallel have the same slope. So I'm going to keep the same slope all the way over here. Well, that means that this angle 1 would have to be the same measure as this angle 3. Okay, they would have to be congruent. Okay, so in this particular diagram, angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Angle 5 is congruent to angle 7, you can see there. And angle 6 is congruent to angle 8. All right, using this postulate, let's try a couple of examples. All right, here in this figure, they tell us the measure of angle 11 is 51 degrees. So I'm going to go ahead and mark that. This is our angle 11, 51 degrees in there. They want us to find the measure of angle 15 and tell which postulates or theorems you used. Basically, find angle 15 and tell us how you know. Okay, so angle 11 and angle 15 are corresponding angles. Now, line X and Y that form these two angles are parallel. Okay, so when the lines that form corresponding angles are parallel, I know they have to be congruent. I'm going to mark them congruent. In this particular case, I have an angle measure for 11, so I can conclude that angle 15 must have the same angle measure. They're going to be congruent. All right, same idea here. They tell us the measure of angle 11 is 51 degrees, and this time they want us to find the measure of angle 16. I'll highlight that over here. This is our angle 16. Okay, so how are we going to get that? Well, these are alternate exterior angles, but we haven't learned the alternate exterior angles theorem yet for when lines are parallel. Notice again that line X and line Y are parallel, okay? And let's see if we can work our way through this puzzle. We do know that angle 11 and angle 15 are going to be congruent because they're corresponding angles and the lines that form them are parallel. So angle 15 is going to have to be 51 degrees. Hold on. See something here? Angle 15 and angle 16 are vertical angles. So angle 16 is also going to be 51 degrees. Good. Okay, in this example, we have this figure where line A is parallel to line B, and the measure of angle 18 equals 42 degrees. Could we find the measure of angle 22? Okay, I'm going to label what we know. They gave us some information here. The fact that line A is parallel to line B, I'm going to mark that. Okay, that's very important. And they also tell us the measure of angle 18 is 42 degrees. So this angle in here is 42 degrees. Good. Could we find the measure of angle 22? Okay. Well, what's the relationship between angle 18 and angle 22? They're both on the same side of the transversal. They're both on the upper side of their corresponding lines, on the same side of their corresponding lines. So those are corresponding angles. And when the lines that form them are parallel, we know they are congruent, and therefore angle 22 is going to be 42 degrees. Okay. If you're thinking, I could find all of those angles right now, you're absolutely right. How could we do that? What do you want to go after next? Shall we get angle 21? Well, 18 and 21 are vertical angles, so we could call that one 42 degrees. Okay. Can we get angle 20? Well, 18 and 20 form a linear pair, so we know they're going to be supplementary. So 180 degrees minus 42 would give us the measure of angle 20, which is 138 degrees. And angle 20 and angle 19 are vertical angles. So there's another piece of the puzzle. Vertical angles are congruent. Down here, we can do the exact same thing. 22 and 25 are vertical angles. They're going to be congruent, so that's going to be 42 degrees. If I wanted to, I could go for angle 23. I could note that 23 forms a linear pair with angle 25 or with angle 22. Either one, it doesn't matter. So 180 minus 42 gives me that 138 degree angle there. And then I can say, hold on, 23 and 24 are vertical angles. They're going to be congruent as well. So when you get a puzzle like this, with just one piece of information, you should be able to pick out all of the angles. Okay, so because of what we just noticed in that last problem, we're going to pull in some more theorems here. It turns out that we have this alternate interior angles theorem. And if two parallel lines are cut by a transversal, then each pair of alternate interior angles is going to be congruent as well. Which angles are those? Well, when we have these lines, the interior angles are in between them. So 1, 2, 3, and 4 are interior angles. Which ones are the alternate interior angles? They're the ones who are on alternate sides of the transversal from each other. So angle 1 and angle 3 are on alternate sides. Angle 2 and angle 4. Okay, so we know that when these lines are parallel, don't forget those symbols, very important. When these lines are parallel, the alternate interior angles will be congruent. 1 will be congruent to 3, and 2 will be congruent to 4. Notice I'm giving 2 and 4 two arcs because they're not congruent to 1 and 3, but 1 and 3 are congruent to each other. Okay, how do we know this is true? Okay, well, let's pretend that we had some other angles in here, 1, 2, 3, 4. Let's pretend we had some angles 5 and 6, right? So we already know from our corresponding angles postulate that if these lines are parallel, angles 1 and 5 will be congruent, okay? And 5 and 3 are vertical, so they're going to be congruent as well, okay? So that's how we know that the alternate interior angles will also be congruent when the lines are parallel. Now, what about the other interior angles? The other type of interior angles we talked about were consecutive interior angles. What do you think is going to be true about the consecutive interior angles when the lines are parallel? Okay, angle 1 and angle 2 are consecutive interior angles. They are on the same side of the transversal. They're both on the interior. They are one after the other consecutive. Likewise, 3 and 4 are consecutive interior angles. Now notice, if I could just cut out this angle 1 and just drag it over here, wouldn't it fit nicely right in there? Yeah, and so wouldn't that mean that angle 1 and angle 2 would be supplementary? Well, it turns out that when the lines that form consecutive interior angles are parallel, those angles are always going to be supplementary, okay? When the lines that form consecutive interior angles are parallel, the angles are going to be supplementary. 1 and 2 are supplementary, 3 and 4 are supplementary. And then the last one we have are our alternate exterior angles. Remember, our exterior angles are out here on the outside of both lines, okay? And our alternate ones are on alternate sides of the transversal. So 6 and 8 are alternate exterior angles. 5 and 7 are alternate exterior angles. And when the lines that form them are parallel, as they've noted here in the diagram, the alternate exterior angles are going to be congruent, okay? Again, how do we know this to be true? Well, let's pretend we had some other angles in here. Maybe I'll say angle 1 and 2. Now, 1 and 5 are corresponding angles, aren't they? Okay, they're on the same side of the transversal, in the same side of their corresponding lines. And when the lines that form them are parallel, we learned our very first postulate in this lesson that those angles are congruent. So if 5 is congruent to 1, well, 1 is congruent to 7 because they're vertical angles. Okay, and that proves that the alternate exterior angles, are going to have to be congruent when the lines that form them are parallel. All right, let's see what we got next. One more theorem before we try some problems with these, and that is our perpendicular transversal theorem. So in a plane, if a line, pretend T is our line, it's a transversal. If a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. Okay, and this should come as no surprise because this is really just an extension of our corresponding angles postulate, isn't it? What if I pretended that this angle was 1 and this angle was 2? Okay, so lines A and B are parallel. Okay, and we've got this angle 1 and angle 2. They're both on the same side of the transversal and the same side of their corresponding lines, so they're corresponding angles. When the lines are parallel, they'll be congruent. Okay, so these two angles will always be congruent when the lines are parallel. If one of them's 90, the other one's going to have to be 90. So if a transversal intersects one of two parallel lines at a 90-degree angle, it's going to intersect them both at a 90-degree angle. All right, here we've got a diagram that represents the floor tiles in Dave's house. Okay, if the measure of angle 2 is 125, could we find the measure of angle 3? So 125 degrees. If that angle 2 was 125, what would this angle 3 be down here? What's it going to be? Well, what's the relationship between angles 2 and 3? How are they related? Okay, we could say, well, they are created by these lines. Let's call them A and B. Okay, and if these are floor tiles, I think we can assume that these are going to be put in parallel. I think the joints between floor tiles, if they weren't parallel, they'd be a real pain in the neck to install. So we're going to assume that based on what they're telling us, that those are parallel. Okay, we can't always assume that. Okay, but if these lines are parallel, and then 2 and 3 are created by this transversal here, let's call it T, then what's the relationship between angles 2 and 3? Well, they're both on the interior of A and B, and they're on alternate sides of the transversal, so they're alternate interior angles. And what do we know about the alternate interior angles when the lines that form them are parallel? They're going to be congruent. So if angle 2 is 125, angle 3 is going to be 125 as well. Could I figure out angles 1 and 4 based on this? Well, hopefully you recognize that angles 1 and 2 form a linear pair, so they're going to be supplementary. And that means that 180 minus 125 is going to leave us with 55 degrees. Okay, those two angles have to add up to 180 because they're going to form a straight line, being a linear pair. Likewise, 3 and 4, you could say, oh, they're a linear pair as well. Or at this point, you could say, I know angles 1 and 4 are alternate exterior angles. And when the lines that form them are parallel, the alternate exterior angles will be congruent as well. Good. All right, here's a fun problem. We're going to mix in some algebra with our new geometry ideas. They tell us that if the measure of angle 5 is 2x minus 10, I'm going to go ahead and label that. And the measure of angle 7 is x plus 15. Could we find x? Okay, well, what do we know here? we know that angles 5 and 7 appear to be formed by these two lines, Q and P, and this transversal M. Okay. Furthermore, we know that M and N are parallel to each other, but more importantly, for these two angles, P and Q are parallel to each other. Notice they have two arrows each. So these two are parallel to each other. And what's the relationship between these two angles? They are both on the same side of the transversal M, and they're both on the lower side of their corresponding lines, both on the same side of their corresponding lines. So these are corresponding angles. And when the lines that form them are parallel, these guys will be congruent. If these angles are congruent, can I find an equation that will help me solve for x here? Well, these angles will have to have the same measure, and that means that these expressions will have to have equal value. So 2x minus 10 must equal x plus 15. I can subtract x from both sides here. And if you want, I can add 10 to both sides at the same time. I get x equals, those are going to cancel, those cancel, equals 25. Okay. Did we answer the question? Don't forget, always go back and read it one more time. In this case, they wanted us to find x, so we're good. Sometimes they want to know the angle. If you wanted to find these angles, you could plug x back in and find them. All right, could we try one more of these? And you might want to pause the video and try this one on your own before I go through it here. If the measure of angle 4 equals 4 times the quantity y minus 25, and the measure of angle 8 equals 4y, could we find y? Okay. This is a little trickier. Okay. We do have, again, two parallel lines, P and Q. We have these angles 4 and 8 that are formed by this transversal N. But what's the relationship between them? We didn't actually talk about the relationship between these two angles. We call these same side exterior angles. We didn't really talk about them, but we didn't really need to talk about them because with all those other relationships, you can work your way through the puzzle and get these things connected. Rather than looking at the relationship between angles 4 and 8, could we look at the relationship between angles 8 and 6? Okay, 8 and 6, hopefully you recognize, are corresponding angles, right? They're on the same side of the transversal, in the same side of their corresponding lines. So what do we know about corresponding angles when the lines that form them are parallel? Well, they're each going to be congruent. So if angle 8 is 4y, what's the measure of angle 6? That's also 4y. All right, now can we find an equation? What do we know about the relationship between angles 4 and 6? They form a linear pair. What do we know about linear pairs? They're always going to be supplementary. So these two angles, 4y plus 4 times y minus 25, should equal 180 degrees because they're going to be supplementary. Okay. Can we solve this for y? Let's go ahead and distribute that 4. Okay, so we get 4y plus 4y minus 100, right, equals 180. Okay, combine like terms and add 100 to both sides at the same time, and I get 8y equals 280. Okay, and when I divide both sides by 8, okay, I'm going to get y equals, what am I going to get? 35. Does that sound right? Yeah. And is that what they wanted us to find? In fact, it was. Always go back and read that one more time to make sure that we've answered the entire problem. All right, one last problem, guys, just so you can get the hang of this. Pause the video if you want to try this one yourself. Looks like there's a tiny twist here in that I see two variables. Let's see what happens when we get this thing labeled up. If the measure of angle 1 equals 9x plus 6, and the measure of angle 2 equals 2 times the quantity 5x minus 3, and the measure of angle 3 equals 5y plus 14, could we find x? Okay. Well, sadly, it doesn't look like we're going to need a system of equations to solve in spite of the fact that we have two variables. I think we can go after one variable, plug in what we know, and then go after the other variable. What variable should we hit first? Well, it looks like we've got enough information to solve for x if we can establish a relationship between these two angles here. Okay, notice we have parallel lines A and B. That tells us they're parallel, cut by this transversal C, which forms these angles 1 and 2. And what's the relationship between angles 1 and 2 here? They're both on the exterior of these lines. They're on alternate sides of the transversal, so those are alternate exterior angles. What do we know about alternate exterior angles? When the lines that form them are parallel, they're going to be congruent. So that means these angles will have equal measure, and these expressions must have equal value. So 9x plus 6 must equal 2 times the quantity 5x minus 3. Good. Can we solve that for x? Let's go ahead and distribute that too. Okay, so we got 9x plus 6 equals 10x minus 6. Okay, the 6's will cancel, right? I can subtract. Oh no, they don't cancel. I've got a positive 6 and a negative 6. They don't cancel. Sorry about that. So I'll add 6 to both sides, and I'll subtract 9x from both sides. And so these will cancel, and I'll end up with 12 equals x. Good. So we found x. They didn't ask us to find y, but guess what? I'm going to ask you to find y. Okay. How do we find y now? Well, we only have one expression with y in it, so we're going to have to relate it to something else that we know. Turns out that angle 2 now we can find because we know 12 equals x. So this is 2 times 5 times 12 minus 3. Okay, you guys hear my dog barking out there? I think she's barking at a chicken. All right, and that's going to equal 2 times 5 times 12 is 60. Minus 3 is going to give me 57. And 2 times 57 is going to be 114 degrees. Okay, so if angle 2 is 114 degrees, and angles 2 and 3 are formed by these lines C and D, which are cut by this transversal B, and C and D are parallel, and what is the relationship between angles 2 and 3? They're both on the same side of the transversal, same side of their corresponding lines. So those are corresponding angles. And we know when the lines that form them are parallel, the corresponding angles will be congruent. That means these two expressions will have to be equal. And can we use that to go ahead and find y now? 5y plus 14 must equal 114. Okay, we'll subtract 14 from both sides. And I get 5y equals 100. Okay, and when we divide both sides by 5, we're going to find y equals 20. Okay, all right, guys, I hope you found this lesson helpful. This is one of my all-time favorite lessons. It's really satisfying after that last lesson we had where we learned the relationships between these angles when we have two lines cut by a transversal. Now, when those lines are parallel, there's all sorts of free information that you can pick out of problems and make them easier to solve. So I hope you found that helpful, and look forward to working on these problems with you guys. Thanks.